I'm Danica Bunnett with Bluon Energy. We are going to be talking about evacuation today. I have Mike Mabry here, our Director of Systems and Technologies, here to chat with us. So Mike, would you mind telling us a little bit about what you do?
Sure. I'm at Bluon here. I'm part of the technical team. My biggest focus is to turn around and deal with larger systems and the systems that are a little bit outside the norm to figure out what needs to be done to convert to DX20 to make our customers' life a little bit easier so that they don't deal with the problems. We've already figured it out and make them aware of what they need to do to make their job easier.
Awesome, awesome. And so to kick off this conversation, I'd like to talk about what some of the steps are in evacuating a system. Can you go through those?
Certainly. One of the things I like to do is to make sure that my equipment's in good working order. If you've got gaskets in your hoses that are all cracked and full of dirt and everything, you're not going to get a good seal. One thing is to remove as many restrictions as possible. You don't want to have a lot of extra connectors or connections that can leak. So get rid of the Schrader cores. I like to use the Appion Megaflow hoses and make sure your oil's good in your pump. I think one of the things I like to do is to turn around and connect my pump with a hose to my micron gauge and make sure that the pump will pull a good vacuum. Because if the pump won't pull down, putting it on a system, it's never going to pull down. You'll just be spinning your wheels waiting days for nothing to happen. So
right, so you might as well try it on the hose first to see.
Exactly.
That makes sense. And why is pulling a good vacuum really all that important?
Well, moisture inside of a system is a problem. So you want to get any kind of air or moisture or contaminants out of the system. Another thing that's really important is that with the refrigerant laws and EPA and everything, if you don't have a tight system, the system's going to leak. It's going to be expensive, it's going to be costly repairs. So if you pull a good vacuum and it holds a good vacuum, then you know you've got a tight system that's not going to leak. So it's very important.
So it's one of the first steps in the process, and if you do that well, then hopefully everything will flow well after that.
Yes.
That makes sense. Sets yourself up for success. And what can expedite this evacuation process? Are there tips or tricks that you have?
Well, using the larger hoses, avoiding using manifold gauges that are going to be a restriction, getting the Schrader cores out of there, which are another form of restriction, larger hoses, make sure your vacuum pump is in good working order, that the oil's been changed recently, and the shortest hoses, the least number of connections. I like to use the Nylog as a thread sealant, just to kind of help make sure that everything is tight with my connections.
Right. So that makes a lot of sense. And can you explain what a triple evacuation process is?
Triple evacuation is a way to help with the evacuation process. If you've got a lot of moisture or contaminants within the system, what you do is you pull as much as you can, and then you introduce nitrogen typically, and run the nitrogen through the system. That'll help to absorb some of the moisture and everything, and then you go ahead and bleed that down and evacuate again. Typically you do this 3 times. It's just a way to help remove the moisture so the pump's not having to do all the work. The nitrogen flowing through kind of picks up and carries the nitrogen through.
Okay, and why would you use this method as opposed to some of the other normal methods?
Well, for example, we're working on a 400-ton system recently, and it was taking forever to evacuate. You know, it was cold, a lot of oil in the system. So by pulling it down and then breaking the vacuum with nitrogen, just flowing a little bit of nitrogen through the system, and then pulling it down again, we were able to get a good deep vacuum, and then we were able to make sure it held and everything, so we had a tight leak-free system.
Cool. Very nice. Do you have any last thoughts on pulling a good or evacuating a system for the guys out there?
It's important to pull a good vacuum. I mean, I can't emphasize that enough, because if you don't pull a good vacuum, chances of having leaks and contaminants in the system are going to lead to callbacks, excessive costs, and everything else. So if you take that little bit of time to do it right up front, you're not going to have the problems. Plus, it's a great way to check and make sure that you got a tight system that's leak-free.
Right.
So
awesome. Thank you so much.